My name is Carlo Cafiero. I work for the United Nations Food and Agriculture Organization, which has been already mentioned several times. But I have to make a very important statement that in this occasion I'm here in my personal professional capacity. Nothing of what I say should imply any opinion whatsoever on the part of the organization that I work for. Having said that, I am responsible for all the figures that Jasmine showed. So if somebody wants to blame anybody for why we still have food insecurity in the world, it's my fault. Because I put forward the numbers that then gets presented, disseminated, read correctly, sometimes misinterpreted. And so the topic of this presentation today is trying to make some clarity on what do we mean when we say that we measure food insecurity. And I will go through 4 steps in my presentation. And the first thing, I want to start from presenting a problem of, do we understand each other when we say food insecurity? What do we mean? And I would say that because it is very important, if we want to measure something, the thing that we are measuring should be unambiguously, clearly defined. Otherwise, all the rhetoric of precision, neutrality, scientific nature of quantification is lost. Because we may have a number, but everybody in our mind attach it to different things. So, once presented the possible operational definition of food security for measurement purpose, I have to make a small digression on, okay, but can something like that be measured to start with? What measurement really means? And we will make some clarification on what is the difference, for example, between a metric, a measure, and an indicator. And so what is truly quantitative information and what is more qualitative, generic information. And then that will bring me to the core of the presentation, which is the development and the use of food insecurity measurement scale, and in particular, experience-based food insecurity measurement scales. And I will conclude with presenting what is the current status and what, in my opinion, are the prospects to bring this research agenda forward. So let's start with what is food security or food insecurity. And if you just do a Google search of food security and then you say, okay, show me the images, you see all these things, which is a mess. And I apologize because I'm also part responsible for this, because a couple of these I have put my hands on. But the problem is there are so many ways in which you can conceptualize food security that from the measurement point of view becomes a nightmare, because you start confounding things. And this is the same definition of food security that Jasmine has already presented. It's from the 1996 World Food Summit. And more recently, the researchers, part of the high-level panel of experts of the Committee of World Food Security, have identified 6 dimensions. So we are now beyond the 4 traditional dimensions of access, utilization, availability, and stability, adding agency, which, by the way, I consider a fundamental aspect of all this, and sustainability as different from stability. But again, if you look at this from a measurement point of view, it's really complicated, because this is something that is an ambitional statement. But in practice, if we take it seriously, food security will never exist. Because at any moment, any time, there will be somebody somewhere who's not eating the food they want. So this is very interesting as a concept, but for measurement purpose, we need to be more specific. There are hundreds of ways in which you can depart from an ideal situation of food security, and then you enter into food insecurity. And each of these different ways can actually, in principle, be measured in its own way. So one thing I want to really make sure that in my current interpretation, the best way of understanding food security is recognizing that food security is not food availability. You go in many parts of, especially the Middle East, the Arab world, when you say food security, immediately people think food stocks. Do I have enough reserves of wheat? But that's not what I mean by food security. In other cases, including some of the presentations today, there seem to be an implicit synonymous between food security and food consumption. You are food secure if you consume enough food. And Jasmine was clear to say no, that's one aspect, but it's not it. And the presentation before, we heard about speaking of indicators of child malnutrition as indicators of food insecurity. But I want to stress that food security is not food consumption, is not food availability, is not adequate nutrition, but is something that is related to or instrumental for all of these things. So the best way to conceptualize is probably think of it as a theoretical construct, an idea, a concept that tries to convey the general idea of a person is food secure when he has no limitation, no constraint in her or his own ability to access food. So a person is empowered, is free to make his own, her own food choices. And if we recognize this constrained ability to access food as food insecurity, immediately we have also an idea of there may be different levels of severity of this problem. So there might be people for whom the constraints are so heavy, so binding, that they can do nothing, and people who may have constraints that allow some flexibility, some choices, but not full. And so here we have a definition of a construct that in principle can be measured, but how to do it. And so in this way, I am placing what is being measured these days, today's, through experience-based food security measurement scale as people's ability to acquire or consume food in the context of what are the determinants and what are the consequences. But in a conceptual framework like this, we should identify where the measurement happened. Because in principle, we might try to measure all these things. So far, I think that the definition presented by Kathy Radimer, who's a researcher at Cornell University, who passed away a few years ago, unfortunately. But she did an interesting ethnographic work of interviewing people who were going through hardship and talking to them, describe what does it mean to be food insecure. And they concluded for this definition, which I strongly support, food insecurity is inability to acquire or consume adequate quality or sufficient quantity of food in socially acceptable ways, is something that the FAO definition, for example, has sort of swept away, or the uncertainty that one will be able to do so. So giving also this idea of the expectations of what is going to happen. Even if today I'm eating, I might be uncertain about tomorrow. Now, a conceptual construct, a theoretical construct, an idea, which is, by the way, most of the things that we work with in the social science, in the human behavioral science and the social science, our object of interest are ideas. It's not physical material things. So, question, can we measure those things? Because measurement is actually something quite specific. And I think it's often abused, the way we speak of measurement, when we describe processes, analytic processes and things that is not truly measurement. And too often, I think that people speak of variables, so numerical variables, as if they are measured, when in reality, we don't know what are measures of. A measure is not simply attaching number to object. A measure is attaching number to object in a way that the numbers represent the magnitude of a specific attribute. That is measure. So we don't measure objects. We measure attributes. And the attributes that we measure must have a magnitude that it's useful to compare. That's why we measure, because we want to make comparison. And to do that, so at the minimum, we need to define the measure, the attribute, and then the way in which we attach the numbers should lead to a one-to-one correspondence, a one-to-one between the number and the magnitude, so that my measurement system should produce a digit that is, let's say, twice as large if and only if the measurement is applied to an object where that attribute is twice as big. So there should be one-to-one, and only that. So, for example, if we speak of child malnutrition, that cannot be a measure of food insecurity, because there are other reasons why a child may have small weight. For example, health, no? Infection, some affection that prevents the absorption of food becoming malnourished, but that's not the same thing as that child did not have access to food. So, this is the current definition is related to a theory that is called the representational theory of measurement, which, by the way, applies also to physical science these days, because even the idea that we can exactly observe and touch the physical matter is being questioned. What we know about the physical matter, if you go deep into it, we don't know. We have models of it. We have this idea of the atomic structure of the matter, but physicists since a long time have recognized that a lot of things that would be very interesting to measure cannot be observed. And so this remains latent trait. And so the question has been debated for a long time, and whether this theoretical construct, unobservable characteristics, can be measured at all, has been disputed. And now we have the additive conjoint measurement theories, the theory that prescribes which property we should verify in order to claim measurability. And Because of this, even unobservable latent traits, things that we don't touch, in principle can be measured. If we are able to identify a set of observable pieces of information that are related to the unobservable attribute that I want to measure. So the idea of additive conjoint measurement is to derive the measure of something that exists, is there, even though you will never really touch it, through the consequences that this thing has in terms of observable fact. And the tool to do this in a way that what you obtain as a number on a numeric scale is truly a measure is the Rush model. The Rush model is an interesting analytic device that combines measurement theory and statistical inference, that recognize that no matter how much effort would you put into the measurement exercise, there will be some residual uncertainty, something that cannot be resolved. And so the proper way to derive inference from measures is in probabilistic terms. Here comes the statistical inference. The Rush model, I will try to be as simple as possible to illustrate it, but I think it's important to fully understand what is behind, because if you don't understand the logic behind it, interpreting the results of application of the Rush model in constructing measurement scales will be very difficult. So, what is the Rush model? The Rush model is a probability statement. And it states that the probability that I observe something, in this formula, the xij is my data. The thing that I have collected, for example, through a survey or through an inquiry, and I have recorded this information. But there is a difference between x, my data, and A. A is what I want. A is the measure of whatever I am applying this model. So in our example, this would be the level of the severity of the food insecurity experienced by a certain individual or household. So I'm interested in A, and I observe X. The Rush model says that if you have a set of items, these are what is captured by the B parameters, that are related to what I'm interested into measuring, I can measure if the probability that I receive a certain response when the subject is solicited with that item is a logistic function. That formula exponent of a minus b divided by 1 plus exponent a minus b is the logistic function. It's a very useful function for describing probabilities because it goes from 0 to 1, is always monotonic. So what is saying the Rush model? That the probability that I obtain a certain answer if I ask a question to a person is a function of the distance, A minus B, between the position of the respondent on the measurement scale and the position of the item on the same measurement scale. So if we interpret A and B as measures of severity, we are talking of severity of the respondent, the household, the individual, and severity of the experience. So just let me anticipate the experience-based food security measurement scale. Ask question like, during the last 30 days or 12 months, did it ever happen that you had to skip meals because you didn't have enough money for food? And the answer is simply yes or no. So my data is a yes or no. My Xij is either 0 for no or 1 for yes. But what are the other terms? The other terms is my food insecurity and the food insecurity severity level of skipping a meal. And so what the model says is that the larger the distance between the position where I am on this scale of severity and the position that I can attach to the experience of skipping a meal, if this distance is larger, the probability of receiving yes as an answer is very high. The logic is very simple. Now imagine somebody asks me, I'm an officer working for FAO, paid unreasonably high amount of money for the work I do. I don't have problems really. So if somebody asks me, which on the food insecurity severity scale, I'm at the food secure extreme. My A number is very, very low, is negative. And you ask me something that implies food insecurity. So the B is somewhere in the food insecurity range. So A minus B, it's a negative number because B, the severity of the condition, is higher than my condition. So what do you expect? My answer would be no. It never happened. And this is the full logic of the Rush model, is that if you ask a very food insecure person, so this horizontal axis now, imagine, is the range of severity levels from food secure to extremely severely food insecure. If you ask a food insecure person whether something that is relatively mild happened, the probability of receiving yes as an answer is very high. This is what the Rush model tells. This is what the logistic function tells. On the contrary, if you ask a relatively food secure person, me, the same question, because now I'm on the other side, the model will predict a very low, close to zero probability of saying yes. So we can imagine a food insecurity severity measurement scale as a set of items, each of them located at different levels of severity. Some experience are milder, others are moderate, others are serious. And then what we do when we collect the data, we collect answers to each of these questions. So for example, if I interview somebody that is located at that position A, I ask item 1, item 2, item 3, I know that the probability of receiving yes to item 1 is quite high. The probability of receiving yes as an answer to item 2 and 3 are lower than 50%, are quite low. So this makes a link between the data, I only observe the answer, and the underlying unobservable measure that I want to obtain. So in practice, how do we do it? I devised this little animation. So imagine that now, if I knew where the person is, it would be easy to predict the response. So if I ask this person about conditions that are less severe, I'm expecting that the answer will be yes. Whereas if I ask the same person conditions that are more severe, the answer will be no. This is what the model implies. But our problem is that we don't observe, we don't know where the person is. We want to infer. And we only observe the answer. So imagine that I have this sequence of answers. Yes, yes, no, no, no. And I have to guess. This is the statistical inference process. I have to guess where this person is. Could be there. Well, if you think about the logic and if you have understood what is behind, you should realize that no, it's unlikely that a person who is located down there would have said no to all these items that are on the left. And therefore, if you keep doing this, you should realize that the most likely position, the one that is more consistent with the observed response, is a position that is in between the first two and the rest of the question. So this is heuristically the way we do it is an application of the maximum likelihood principle to estimate the parameters A and B of our model. What is the severity that is more likely to be the right one, even though I will never know for sure? I can only estimate, I can only infer, given the answer that I have observed. So I will skip this. This is also one way in which we practically do it. Well, let me try. I'm monitoring my time, so I will use my 1 hour, so we don't have, we will have questions at the end. This is like the data would look like. Imagine you have asked a set of 8 questions to n different subjects in your interview, and these are the response. 1 means yes, 0 means no. You have this data in a tabular format, and then what is behind the Rush model analytics is that you first observe the frequency of the yes responses that have given to each item. So you are using the sample of individuals you have interviewed as providing you some information on, in that context, in the context of where these people live, which of these items is more frequently reported and which of these items is more rarely reported. And the idea is that if something happens often, or if something happens to many people, it must be something relatively mild. The more severe a situation, the rarer it would be. So I can claim that if one of these items has been reported by very few people, it must be the extreme situation. If it is true that these items indeed are all related with each other because they all refer to the same latent trait. So if we are talking of items that have to do with food insecurity, and only with items that are related with food insecurity, then the things that is reported less often must be the more severe. And based on this, I can order my items in terms of severity. And this is a first important concept that often gets misunderstood. The severity order of the items is a result of the analysis. It's not something that we know a priori, that we know before collecting the data, because it may change. In different contexts, in different cultural, natural, social, environment context, the relative severity of this experience may change. But that's not a problem, because the actual severity ranking is the result of analyzing the data. So in this made-up example, because question number 2 has been answered less frequently than question number 3, I need to recognize that the order 1, 2, 3, 4, 5 in which I ask the question is not the order of severity, but I need to switch. Now I'm ranking them in order, decreasing order of frequency. So this means that now I know which items are less severe and which items are more severe. Once I do that, I change my perspective, and instead of looking at the items, now I look at the people. So I analyze each person. And what I do, I say, okay, how many answers, yes answer I have received. And so, for example, the first person has said yes to 5 items, the second to 2 items, the third to 8 items, all yes. So I'm computing what is called the raw score. The score is the sum of the affirmative answer. And now I do that exercise that I showed you before. Let's look at the first person. It's a person that has said yes to this first 5 items and no to the next 3. So if I have to guess where that person is, that person would be somewhere here. Okay? Pretty easy. When things become complicated is that now look at person number 6. Person number 6 has also answered yes to 5 questions, but they are not the same. So now I should try to guess where is person number 6. That is one possibility, the question mark. Can it be there? That is where he switched from saying yes, then no, for the first time. But then, if the person is there, how do I explain these 2 answers? So this would be strange and difficult to explain, and therefore I have to make another guess. What about here? That is another possibility, but yet, if that were true, how would I explain this? And now this is the main concept that is embedded in the Rush model and is a consequence of demanding that the measurement is consistent with those principles that make it a proper measure, is that to be true, the best guess for where this person is exactly the same as the first one. It seems like strange, but it is the result of the fact that no matter how I do the process, there will be always some uncertainty, some measurement error. The important thing is that I balance in the proper way this error. So in this case, there are 2 unexpected responses, one to the left, one to the right. But because of those, they balance each other, and the estimate of the severity is only dependent on the raw score. Technically, under the truth of the Rush model, the raw score is a sufficient statistics for the severity parameter A. I'm speaking now technical language for those who are trained in statistical inference. This is one example of a sufficient statistics. And what is the difference between the same number they attach to individual 1 and individual 6? I'm attaching the same number. However, I am much more confident that on the measure attached to individual 1, I'm a little less confident of the measure that I attach to individual 6, because there are some strange things still there that I don't fully explain. And so this is the basis of the statistical inference that allows validating a potential, a measurement scale as being truly capturing a latent trait or not. Because in the end, what I can do, I can actually conduct a test of how close the data adheres to the restriction imposed by the model. And I do this by computing some residual, which is something that we often do when we do statistical inference. And based on the residuals, I can precisely assess validity and reliability of the measurement scale. So that even though I might have a good idea, good knowledge of what should be part of my measurement scale, I always need to empirically test, because that scale might not work in a certain situation, and I have to be aware. Not only, I also have a measure of how precise can those measures be. So I can assess validity and reliability, which are the fundamental property of a measurement scale. And so the Rush model can be used to create measurement scale for latent traits. However, before concluding that you have a valid and reliable measurement scale, you have to go through the test. And the test has to verify that indeed all items have the equal discrimination power. They contribute information on the same latent trait in an equivalent way. And also the answer to those items, the responses to those items must be conditionally independent, means that apart from the fact that they convey information on the same thing, the response to each item should be independent from each other. So if I say yes to having skipped a meal, and then I say yes also to going for a whole day without eating, the only reason why these are the same is because they are both measuring the same tool. There should be no other reasons, which may be, I interview some people during, Muslim people during Ramadan, and might be some other reasons why in certain moment people, irrespective of their food insecurity, respond to this question in the same way. So we need to make sure that all else that may condition the response is not systematically revealing something. And this is done by analyzing the structure of these residuals. Technically, we have a set of data. We do quantitative analysis. It's like a factor analysis for those who know what a factor analysis or principal component analysis. We try to extract the first component, the main factor. Once we have extracted that, everything else should be pure random noise, pure, no structure in the residue. So this is how we do this. A very important point, and this is the last of my more analytic, dense presentation. In the end, remember that I said the person with the same raw score will receive the same measurement. However, I'm not equally confident that I am getting the right measure. What this means that the way in which the information is processed is that revealing the raw score, the sufficient statistic, is not enough to pinpoint exactly the severity. The only thing and the best thing I can do is that I can attach an entire distribution to each raw score. I know that the higher rho score, the higher is the expected severity level. Therefore, the mean of this distribution are ordered along the severity scale in an increasing order. The rho score is an ordinal indicator of the severity of food insecurity. However, rho score 1 and rho score 2 are not at the same distance than rho score 2 and rho score 3. So it's an ordinal, but even though these are numbers, 0, 1, 2, 3, 4, I cannot consider them real numbers. These are just labels attached in an ordinal manner. Moreover, there is uncertainty. So it is true that on average, a person with a rho score 1 is less food insecure than a person with rho score 2. But there is some overlap. There is some probability that a person with rho score 1 may actually be more food insecure than a person with rho score 2. And this is something that we need to understand. The ability of a Rush-based scale to really discriminate between individuals is quite limited. Why? Because we have few pieces of information to make our assessment. The only way in which we could make those distributions narrower, and so to be able to more confidently separate individuals, would be to have additional questions. The more items I have, provided this set of all items respond to the validity question, to the Rush model, the more precise I can be. Some of you who are engaged in graduate studies have done the GMAT, GRE, these educational testing processes. Well, all these tests are based on Rush. And those tests, higher education academic institutions ask prospect students to do the test because they want to really identify who's the more competent. You should be in the 95th percentile of the distribution if you want to get accepted at Penn State or at Berkeley. How can they do that? Well, they don't ask 8 questions. When I did the GRE long time ago now, I'm getting old, I had to answer 400 questions. So if you want to gain precision at the individual level, you have to add questions. Okay. So I can move now on how did we use this in the context of food insecurity. First, there are 2 other things. This is also very important. I've always spoken about a scale, but I've never really commented of where is the 0 and what does a unit on this scale means. And the reason why I haven't, because actually there is no way of truly identifying an absolute 0 and a unique unit of measurement. We need, if we want to do that, and it might be useful when we want to make comparison of assessment across population or over time, if we want, we need to set up a conventional reference scale. And people think, okay, but this, how do you do it and why you need to do it? It seems that measurements should be objective, and so what is this arbitrariness of setting a convention for the... But I would respond to that. Think about temperature. Is there anybody has any doubt that temperature can be measured? We do it every day. Yet, temperature is a latent trait. Temperature is an idea. Temperature is not a physical attribute of an object. So it shares many similarities with the things that we measure with the Rush model. And even with temperature, imagine that you want to, I think in India use the Celsius system, right? So a friend calls you from the United States and says, how's the weather today? What's the temperature? You say, oh, today is 35. And he goes, gee, it's terribly cold. Because 35 in the Fahrenheit scale means close to freezing. But you are intending 35 Celsius. So what's the difference? The difference is the convention, the way that sometime, at a certain point, somebody decided, let's set 0 to the freezing point of water. Why? Arbitrary. Convention. What is true with convention is that once you accept that we use it as a calibration, as an anchoring point, as a reference, so that we can transform measures obtained in India with measures obtained in Italy to avoid the confusion of Celsius versus Fahrenheit. We all speak the same language. And we also, on the global reference scale, this is the position of the various items. There are, and this is, again, this is the world average. It may not be true in any specific country. So you may have exception to this ordering everywhere, but this is the prevailing average. So you have 3 items that speak more of the quality of the food. Then you start getting into quantitative restrictions, and then you end with very severe experience like feeling hungry but not being able to eat, or skipping meals for the entire day. And on this we set 2 conventional thresholds that are only needed, appropriate for SDG monitoring. If you are using the FIAS for a different purpose, you can set your threshold somewhere else. It doesn't need to be the same threshold for SDG monitoring. So, my final 5 minutes is on what are the futures. So, where are we now and what we can do later. Now, the FIAS is used in many contexts. We monitor SDG target 2.1. It is used, for example, in Mexico to contribute to the multidimensional poverty index, to capture the food deprivation. We use it also, has been used by researchers. I say we because I contributed to that research, but that is independent from FAO. There is the World Hunger that counts how many food insecure people are in the world every second. So you go on World Hunger IO and you have this counter. And this is based on extrapolation based on the FIAS measure. A recent innovation is that we now use the FIAS with a short reference period of 30 days to assess frequently recent food insecurity in emergency context. So the FIAS is also part of the IPC Acute Food Insecurity Measurement Initiative. It's been used to assess the impact of program in many occasions. It has been used to assess the impact of shock. For example, after COVID, the World Bank initiated a series of high-frequency phone surveys in which they would call every month a sample of the population. They used the FIAS to see how COVID was impacting food insecurity. One very important thing that I've noticed is that I recently made a search of the literature using Web of Science. And today, if you just put FIAS, Food Insecurity Experience Scale, or HFSSM, ELXA, EBIA, you have more than 1,500 hits. Lots of articles. And I have noticed that a lot of articles use HFSSM, FIES, to measure food insecurity in health research, because food insecurity has been established as a fundamental social determinant of health. So now every researcher that wants to understand depression, wants to understand obesity, wants to understand diabetes, they also have data collected with a version of the FIES on the patients. And so there is a huge database in which food insecurity is used as one of the predictors of medical conditions. So it's an established piece of tool for research, very hot topic in academia. So what's next? And this is what my recommendation. My recommendation is that before just copying the 8th question and applying, think about it that you still need to go through the validation, which is specific of each application. So it's not enough to just replicate exactly the same questions that somebody else somewhere else has used. Actually, this is a mistake, because if you use an expression that has been used in the US, for example, literally in India, you may actually convey a different meaning. So rather than increasing the comparability, you are actually creating something else. It's important to recognize this, and it's important to be able to conduct the statistical validation. As I said, also sometimes people make reference to the threshold that we use for SDG monitoring, when probably those thresholds are not the more significant. Maybe if you want to explore the social implication, you want to move the threshold even a bit further than the moderate one, because the moderate food insecurity already gets to a point in which quantitative restriction of food are at place, whereas the psychological consequences, the other things that are associated with being unable to be freely access food are relevant, and so you may need to use a different threshold. What are my recommendations then to those of you? We will have also additional conversation. Be creative. Precision, especially when you deal with small samples, is so important. Try to find additional items. Try to ask more questions that are related to inability to access food, but maybe context specific. So we, for global monitor, don't need to be that precise, because in the end, what we do is just the prevalence at national level. Can you imagine? I mean, a country, a nation like India, a continent like India, we only have a number that is the average, the prevalence, but we don't know where. Whereas for your research may be very important. So you want to be more precise, you'll be able to disaggregate more. So be creative. Reliance on charities, on food assistance. This is something that is becoming more common and common. Why not to make it an item into a questionnaire? In a general population survey, you can ask, did it ever happen that you had to rely on food aid from an food assistance institutions, from the government, from your neighborhood, from the church, whatever? People may say yes, and this is in itself revealing that the household had some problem. Other people may say no. So it's an item that allows you to discriminate. Second, extremely important. What really matters in this area is that the people you ask the question understand what you're asking. Because that is the most precious thing. The information that I give must be an informed response. If they don't understand the question, you are wasting your time. So pay very high attention to cultural and linguistic adaptation of the question. It's not important to repeat the question as is written exactly. It is important to make the person understand what are we talking about. So, enumerator training, that those who ask the question are very competent in what is the principle, what is that we are trying to get, it's probably 90% of the success in applying a FIES scale. With that, I really thank you. It's been a honor and a pleasure, and I look forward to continue conversation on this topic that is here to stay for a long time. Thank you so much.